For 30 years, the Hubble Space Telescope has been staring into the dark, counting the milestones of the cosmos. It was built to answer one specific question: how fast is the universe expanding? But after 3 decades of data, Hubble delivered a number that refuses to fit. It's a number that contradicts the Big Bang. It contradicts our best models of physics. And recently, NASA released the definitive dataset that confirms it wasn't a mistake. The universe is moving faster than it should be. And nobody knows why. To understand why scientists are sweating, you have to understand how we measure the dark. You can't just use a tape measure in space. You need standard candles. These are specific stars, Cepheid variables, that pulse like a heartbeat. By timing that pulse, Hubble can calculate exactly how far away they are. It's the most precise ladder we have. Edwin Hubble used this method a century ago to prove the universe is expanding. And the modern Hubble telescope was built to refine that number, to nail down the Hubble constant. Enter the early universe team. Decades ago, the Planck satellite took a baby picture of the universe, the cosmic microwave background. This is the light left over from the Big Bang. By analyzing that light, physicists used the standard model to predict exactly how fast the universe should be expanding today. The number they got was precise: 67 kilometers per second per megaparsec. That is the prediction. That is what the laws of physics say the speed should be. But then Hubble took the actual measurement. It didn't look at the past, it looked at the present. It measured the stars, right here, right now. And the number it found wasn't 67. It was 73. That sounds like a small difference, but in physics, it's a chasm. It's the difference between a universe that is 13.8 billion years old and one that is much younger. It implies the universe hit the gas pedal somewhere in the last few billion years, and the standard model didn't see it coming. NASA didn't want to announce a mistake. So, the Hubble team spent the last few years tripling their sample size. They looked at over 40 galaxies and thousands of stars. This was Hubble's final shot, the definitive 5 sigma confirmation. The odds of this being a statistical fluke are 1 in a million. The discrepancy is real. The universe is lying to one of our telescopes. Wait, before we rewrite physics, isn't it more likely that a 30-year-old telescope just has a smudge on the lens? That's exactly what the early universe team thought. They said, maybe Hubble is confusing the stars. Maybe dust is getting in the way. It's a valid fear. If your ruler is broken, your measurement is wrong. So, for years, this was the debate. The Hubble tension is just a measurement error. But then, we launched a better telescope. Surprise number 1. The James Webb Space Telescope. JWST can see through the dust. It can separate the stars Hubble blurred together. Everyone expected JWST to fix the error. They expected the number to drop back down to 67. But recently, JWST looked at the exact same stars Hubble did. And the answer? It matched Hubble perfectly. Hubble wasn't wrong. The measurement is accurate, which means the prediction is wrong. The standard model of cosmology, the bedrock of how we understand existence, is missing something huge. So, what is the universe hiding? Surprise number 2. We might be living in a bubble. Some scientists proposed we live in a giant cosmic void, a low-density area of the universe. Matter pulls things back with gravity. If we are in an empty spot, things might expand faster locally. It sounds neat. It solves the math. But recent studies show the void would have to be impossibly large to explain the data. So, that theory is crumbling too. Stop looking at the stars for a second. Look at the energy between them. This brings us to the darkest truth. If the measurements are right, and the void theory is wrong, then the energy of the universe is changing. Physicists are now proposing early dark energy. Imagine a mysterious force that flared up shortly after the Big Bang, kicked the universe's expansion into overdrive, and then vanished. Like a cosmic turbo boost we can't see anymore. If this existed, it would fix the numbers. But it means inventing a new force of nature that we have zero physical proof for. Why should you care if the speed is 67 or 73? Because this number decides the fate of the universe. It determines the age of the cosmos. If Hubble is right, the universe is younger than we thought. It determines if the universe will expand forever, rip apart in a big rip, or crunch back down. Right now, we can't predict the end of the world because we don't know how fast the car is moving. This is the silent crisis. NASA and ESA aren't hiding aliens. They are sitting on data that suggests gravity might not work the way Einstein said it does on massive scales. It opens the door to the dark sector, a whole family of particles and forces that interact with gravity but are invisible to light. Hubble's final shot didn't close the book on the universe. It threw the book in the trash. Right now, it's a standoff. The Hubble tension has reached 5 sigma significance. In science, that is the gold standard for discovery. We have discovered that we don't know what is going on. Theories are flooding in. Primordial magnetic fields, interacting dark matter, a flaw in general relativity. Hubble is an old eye, but a sharp one. Its final major contribution wasn't a pretty picture. It was a question mark. A question that proves the universe still has the power to surprise us. But if you think this tension is weird, wait until you see what JWST found at the edge of time. It found galaxies that are too big to exist, another nail in the coffin of the Standard Model.